Okay, hi everyone. I am Sia. I know it says Kimberly down here, but this is actually Sia. And I am part of the Black Tides Planning Committee for Black in Data Week. I'm also a data engineer. So now we have Pierre, who is very gracious to do this. This is a very for us very special because Pierre is our advisor. He's an advisor to Black Tide. So it's some valuable time we're getting. He's a founder. He's been in analytics, I believe. I cannot say 13 years, so I have to say +3. This is 16 years now. Is that correct?
It's 14, coming
14?
up 14 as of
Okay,
March.
I
So,
added
yep.
it. Yeah, so a lot of experience, founder of Zamana Analytics, and he is going to talk to us today about Acing Advanced Analytics. We'll let him introduce himself a little bit more, but enjoy and thank you, Pierre, for being here.
Thank you for having me. Good evening, everyone. As Sia said, my name is Pierre DeBois, founder of Zamana Analytics, and I have been in business now for about 14 years, but my background is a little varied. Before that, for 8 years, I was an engineer at Ford Motor Company. So if you know anybody driving a 1992 or so Ranger or Explorer, I know that's a little old. Look at the tail hitch. That was my part. Uh, that was part of a dream to work in the car industry. But what got me into analytics was Google Analytics in particular. I had an interest in helping small businesses on their digital marketing, understanding their data. And my first push was through Google Analytics. Now I'm also doing data modeling as well with R programming and just a splash of Python, but still working on it. But what I want to do is get a framework to help you in thinking about the next level for analytics. We've had analytics on the brain now for quite a bit of time, just a little bit longer than I've been in business. But there's a lot of different tools, a lot of different ways of trying to take data and kind of get beyond the basics and where you should start. So this is really kind of a primer. So we're going to do this in a couple of ways. It's a little bit housekeeping. First of all, there's most of these examples, in fact, all these examples are pretty much R programming, but that doesn't mean that for those of you who are Python literate, doesn't mean that you can jump in and kind of take a little bit of framework from this. In fact, I'm actually trying to do an update of this later on where I can talk a little bit about some frameworks with Python that might be of this, or libraries that might be of some help. And then we're going to talk a little bit about time series regressions and sentiment analysis, and a little bit about what you should be doing in data exploration. And then for these three in particular, what you kind of should be looking for. It'll be a little bit heavy on the time series, heavy on the regressions. I have one slide on the sentiment analysis, and I'll explain that in a moment. But it should generally leave you with some ideas how to best develop data for advanced analytics. So you hear this a lot. There's analytics and there's advanced analytics, and a lot of what makes advanced analytics advanced is really, when you start and think about it, is really the complexity that gets into it. But you're trying to go for more value from the data. Most times when people hear analytics, they think of the Greek definition of analytics, which means for breaking down, and it's usually either doing something that's descriptive or diagnostic to a particular activity. When I got into analytics, one of the things that caught my attention was that a lot of when it was called web analytics, and it still is technically, but when it was called web analytics, a lot of it was done as a diagnostic tool. In fact, that's how Urchin, which was the original version of Google Analytics, came into play. It was a diagnostic tool supposed to measure website performance. Today, what's happened is that we use that now for digital marketing. The idea of looking at how a page loads in for a browser, you're making assumptions on people looking at that page and if they're interested in the product or service. What's happened is that beyond the descriptive and diagnostic, what you end up with is data that you may need to be predictive and prescriptive. And you'll hear those terms quite a bit throughout your career. They're mentioned over and over again. But the general idea is that you're now using a little bit more statistics to make your points. So what it is in practice is that you are exploring the data set and you're kind of looking for trends or segments or trends and maybe some deviations that are happening within segments of your data. A lot of times in marketing, you hear the term cohort, which just means a segment of your data representing a type of customer. It could be a customer who could be based in Nevada, for example, a customer who could be based in Miami. It could be customers who normally purchase a product. A certain times out of the month repeatedly over time. And most tools like a Google Analytics, Adobe Analytics, they're very good at sort of getting some of the basic pieces together. Where they kind of throw off is the statistics part, and we'll talk a little bit more about that. But the general idea is that you are trying to analyze trying to create a data model based off of those segments, and you want to see how it upholds statistically. So you can have a very basic trend in Google Analytics, Adobe Analytics, and that's okay. If you have a customer that needs just that basic piece of information of how many just basic information, how many things were sold, how many things were in inventory. That's the type of thing where advanced doesn't come into play. Where it does come into play is the statistics that gets thrown in, which is supposed to basically say, I know that there's a change in this pattern. How sustainable is this change? That's the key thing that you want to remember, no matter what you're looking at or what you're trying to study, is you're trying to see how sustainable something is, because you're trying to figure out if there's a deviation or change, how well that's going to be kept up throughout the time. And most basic tools just don't cover that. It's just not really designed for that, to be honest with you. So what it does is that surfaces missing deviations and trends that really are supposed to be the real reason for the influence. So why does advanced analytics fail? Well, like I mentioned before, there can be initial data and metrics that really are helpful for that first gear to get you moving, but they can fall short in terms of getting the deeper insights for objectives that you're trying to see if it's sustainable for types of customers, types of sales. It could be operational for a business, or even operational for, say, a hospital, the amount of capacity that you need to hold on a regular basis. Those sort of things are based off of trends that you have to kind of see how statistically those things are holding. So occasionally there's two big traps that come into play. One trap is doing more of what you have done before, which unfortunately this happens to analytics. I know you don't have to raise your hand. I know many of you have gone through the same thing, or if you're just starting your career, you will go through the same thing where sometimes people are not that imaginative and they just kind of want the basic numbers, basically, how many sessions happened on my website, or how many users have come to a site. Well, those basic pieces are nice to know, but they're not strategic all the time. And so a lot of times people get too caught up in looking at those basic numbers and running with it. So you have those problems. And then the other problem, which is kind of similar to ties into what I was saying earlier, it's basically over pursuing an opportunity. In other words, you're so tied into these basic metrics that you're over pursuing an opportunity instead of looking at the emerging markets or emerging things that are coming into play. And you see this over and over and over again. So again, you see people doing things that are overly constrained, and then the end result is that sometimes when you're trying to get those strategic ideas, that the team sometimes just do not know what to do next because they're so stuck on the first gear. So what you want to think about when you start playing with metrics, think about them in three categories. This is three categories I kind of thought about a little bit. Vanity, efficiency, and effectiveness. And I'll go through each one. They're very simple to remember. The vanity metrics, and you'll hear that from time to time again, they're again the basic metrics I'm talking about, where people just want to know how many things are being sold, how many people are visiting your website, how many people are coming to this place. It's an inventory of a characteristic if you stop and think about it. So an example could be and it's usually just a basic metric like a conversion, just a number. Okay. The second level gets into efficiency. And this one is a little bit more murkier, but it's still helpful. It's a little bit more helpful, but only somewhat helpful in some ways. And I'll explain the somewhat in a moment. But what efficiency is ratios. And you want to think about in terms of something that you have an interest in versus maybe, say, the time period that it happens, or maybe in some other ordinal number that you're comparing to. And these was conversion rates. Conversion rates are, for those of you who don't know, are the percentage of people who come to a web page. They do an activity that you're interested in. That's a conversion. So the rate would be, number of people who come to a web page. Actually, number of people who come to a web page who convert, who do that action that you want to see, divided by the number of people who come to that page. Period. Okay, so that's a conversion rate. Another thing you will hear about in business is KPIs. That's another ratio, and that's kind of a general. That's a whole topic on its own, but it's just basically a ratio of how things are happening within the business. So ratios can be helpful to make comparisons, to give you a sense of benchmark of how you're doing. So they're kind of a step up, but it depends on again what you are wanting to compare. That's the important part that you'll have to struggle and put together as you're talking to your team. The third level, and this gets into more of the statistics part, is effectiveness. And this gets into a performance lift or decline. And you hear about this all the time. Something spiked, something increased, something decreased. That's fine. But as I said earlier, we want sustainability. So a lot of times you're trying to figure out what is in the data that is creating that spike, that's creating that trend. And is it sustainable? And you form a hypothesis, which is, if you've studied statistics, this is what comes up. So a hypothesis is just saying that when you're forming a hypothesis, what you really are doing is saying, between these two events, I'm trying to determine if one thing, it makes a significant difference versus the other. And that's really what that boils down to. So that's kind of the three tier to think about things when you look at metrics. Now, I'll get into R a little bit. How many people are using R programming? Anyone have not heard? Is there anyone here who has not heard of R before? I'm going to assume that a lot of people have. You can chat, send a message, that type of thing. If I'm going too fast at something, just ping me and say, "Hey, Pierre, explain this." But the idea with this is that when you start playing with data, choose your language. You'll hear a lot of people talk about the difference between R and Python. I'm not one of those people. Most people I run into are usually more interested in the data part. That is really much more important to Ibua. I hope I'm pronouncing that correctly. Now, your current location. Both languages are fine. Okay, thank you. It's a little bit of a nerd debate between Python and R, to be honest with you. I try to stay away from that because what's happened is in the last 4 or 5 years, I could pick something in R and somebody can say, "Hey, I have a library in Python that does the same thing," or I have a library in Python and there's a version available for R. I mean, there's been a lot of development on both languages, but either one is fine. Pick something that makes you feel comfortable in terms of the language, and treat it as a service layer where you have the language and the IDE. Most people use RStudio, and then you're going to use that to access a storage layer, which is basically your data source. Some people, let's see, and with Posit launch, R seems invested in better. Yeah, there's better integration going on right now. Posit is probably the biggest. For those of you who don't know, Posit is the company that owns RStudio. That seems to be pushing a lot more consolidation going on, basically, in terms of knowledge and education right now. But pick what makes you feel comfortable, basically. So that way you can kind of understand a little bit of the structure and the math behind everything. So after you do your metrics, the next step is to think about exploratory data analysis. And this is kind of a fancy term that just simply means you're exploring the data to see what's in there in terms of observations. And what you want to end up with is some sort of orderly table where you have observations going across the rows. Variables are basically each column of different types of variables that you're interested in. Values are each one of those observations. And what you're trying to do is you're trying to get a sense of, spot the anomalies that are going in, the NAs, which are a big deal, maybe unusual values and extreme outliers. And a lot of this, you're going to have to talk to your stakeholders and make sure that when you're exploring the data, that they don't have you exploring it just for the sake of exploring it. So what you want to do is make sure that the stakeholders understand, what type of data you're looking at, what are the boundaries are. We'll talk about that in a moment. But what this does is that it ensures that everyone's on the right page. ensures that you're validating certain business or operational assumptions with the data and making sure that that's statistically possible. I'll get to that in a moment. And you're improving your data quality as a result, basically. So good questions to talk about, in your data structure is think of it as a pedigree. How is this data sourced? Is it just a simple file? Is it an Excel file? Hope not. But if it, but if it is, okay, fine. Is it CSV? Is it API? Maybe it's just it may be a data source. It may even be a feature store. This is a type of database where features for machine learning, you can access and learn a little bit more about what the features are for maybe a large set of data, basically. So there's a lot of intermediaries that are coming into play these days. But find out where it's sourced. You want to ask yourself what types of data exist within the observations. Usually it's units of times for a time series, but which makes it a lot simpler. But you want to be able to know, if I'm going to do a regression and that it's supposed to be on features on cars, am I getting data that talks about size, miles per gallon? What type of engine? Is it a gasoline engine or is it an electric engine? These sort of things help you in kind of knowing what's in the data. Definitely know if a header exists. That's a big deal, because if there is, you may have to take that out on a regular basis. And then the fourth part is just very simply who will share access with the data, how, and it kind of gets into how it's being updated. And also may help you understand who needs to know what from anything that you're reporting. So sometimes that's a good thing to ask. Now, so the next step is you want to think about what are the real world constraints. And I kind of put this picture of a broken truck because I had to explain to somebody once, like, that's not from somebody hitting the truck. It may look like it, but it's not. Anytime you see a truck this bent, it's because they put something in the payload they shouldn't have. And that's the entire point of the slide. Sometimes you're running into things where people have misentered data for different reasons. And you want to be able to put some logic to it. For example, if you knew that your data was with, oh no, Kimberly is not a Ford car, it's a GM. Okay, let's get real. I worked at Ford, so let's hey. So so, but you want to look at certain things like, and it can be just simple stuff like, that if you have miles per gallon in the data, you should not have negative MPGs. That's not possible. You wouldn't have a negative distance for something. If it's somebody who's alive or who's sick or dead, basically, you would not have data saying, oh, this person's more dead than the next person. That would not make sense. Another thing you want to check out is any of the data being self-reported? That's a big deal, particularly if you are using data from a survey. A lot of times, particularly for identity, for gender identity, sometimes people will put NA where they don't see if there's an option. And if you have too many of that, now you have a whole bunch of NAs in your data that might skew some things if you're trying to identify a cohort based on gender, for example. So what you want to do is you want to think about these type of constraints and is it impact or not? And then you want to use some built-in functions to confirm, what's in the data, basically. And most of R has this. Python has it the same way too. In fact, actually, if I remember correctly, Python the same. If I remember correctly, you make a data frame dot head, same sort of description as in here for head and tail. And I think dimension was something different, but knock my head in if I called it out incorrectly. But the point is that what you want to do is kind of get a skim, to take a look at what's in the first several rows, what's the last several rows. And you use dimension to return simple rows and columns, just kind of give ideas to something square or how square it is. There are libraries that can help you to get a little bit deeper into R. We're using R to get a little deeper into the data. These dependencies can help you in terms of kind of seeing how many observations they are, get into things like where there's a median, first quantile, third quantile. Let's see, shape. Thank you. Ebook, that's it. Shape. That's it. Thank you. Thank you. So these are libraries that you add, and you download them from CRAN, basically. In RStudio, there's actually a pane. I can show you this at the end of the slides, but basically there's a pane that you can download the libraries into and load them onto your script. So the one that's really popular, and you'll see this time and time again, is Dippler. Dippler has a number of functions that can help in terms of, it was actually designed to help you manipulate data a little bit more closely like a SQL in some ways. But there's two functions that are really good, glimpse and summary, which returns the number of observations and variables, and it does it in this sort of nicer table than the previous ones I showed. So it kind of gives you a little bit more information. Summary returns quartiles as well. And there's two others that you may want to keep in mind. Skimmer, which skims and returns a number of columns, missing values, empty values, and so forth. So these are helpful if you have a flood of columns and you're trying to figure out, which ones to kind of get into in terms of NAs and missing values and that type of thing. Let's see, how are we doing on time? Okay. So once you kind of do some exploration, then you have to start thinking about what type of analysis that you want to do. And for advanced analytics, there's three sort of areas to get into. You'll see this a lot. Time series has gotten to be, I'm not going to say it's popular, it's just kind of, I'll put it this way, there's more data now that people can use and ingest into either R or Python and build like a time series model for. Regressions are the first step in taking columns of data and figuring out if there's a relationship between the data, and we'll get to that in a moment. A third one, which I think is very interesting, is sentiment analysis. Now, I did a presentation on this back in 2018, did this for O'Reilly, and what's happened is this is a good example of how something kind of got changed based off of the type of data. This has been around for years, and originally people would come and do a sentiment analysis on a paper or a text. And what sentiment analysis is that you're breaking up each word into these sort of, into a corpus, putting them into a digital container, and you're assigning scores of what the sentiment is based on the types of words that are being used. So you kind of get a sense of a document, whether people are happy, sad, maybe miserable, and there's a lexicon that you apply to it. This was originally done for white papers, books, novels, but you can ingest data from Twitter or from basically anything with an API, and bring that in and conduct a sentiment analysis among those things. And when I did this for O'Reilly back in 2018, it was a sentiment analysis on IHOP about the sentiment about the new burgers that they had coming out at the time. So I bring it up this area that a lot of these are just time tested. They've been around for a while. There's white papers on almost everything. It's just that now you have more applications because there's more access to data these days. So you can be a little bit more imaginative. So let's get into, so I'm going to get into the time series one first. And so there's couple key pieces to keep in mind here. The first bit that you want to keep in mind is that anytime you play with data or you ingest, let's say you have a column of data of dates, for example, R tends to treat data as a special type of object, basically. And so a lot of times you may need to convert those for columns of dates into a object that R can recognize. There's a couple of them that have been, there's a couple objects that have been created. TS is one of them, and there's another one I think called Zoom, if I remember correctly. But one of the things you can simply do is right here at the top, you can take a date. You can put a column together of a object that contains a few dates, and you can convert them. That's what you have this as.date function for. R has a number of functions that let you convert from one object to the other. And then you sort of have to tell it what type of format the dates are in order for it to say, okay, it's in this format. I need to change this into an object. At the end of the slides, when I put this deck up, there'll be a chart that will show what each one of these codes are. But a lot of them are just these %M, %D, %Y. That's for month, date, and year. And then then R will recognize them as dates. And you can see that in that first image that there's a difference between having the month/day/year to year dash month dash day. So it's in a format where R can recognize it. That becomes important, particularly if you have APIs and you try to pull data for certain dates. This image at the bottom is from a script I put together for Search Console. based off of Search Console. There's a library for Google Search Console where you can import keyword data in and actually come up with a whole bunch of models. If you look at line 26 and at the beginning of line 27, there's a start date. Again, you can see it's in that same format. And then there's an end date, and there's actually a function sysdate -3. So it's telling R to pull data up to 3 days prior to the current date, and that's what that sysdate is. It's basically it's basically the object where it's telling R to look at the current date, and then you subtract 3 to get to 3 days before current date. So that's just an example of why you would need to do that. And so once you play around with your dates a little bit, then you can kind of start looking at conditional test in time series. Now, the big thing I want you to remember with a time series is that you can get time series data is not how can I put it? I don't want to say it's easy. It's one of those things that is very common. You see that in Google Analytics, you see that in the reports, and kind of you look at number of visits to a web page during time and so forth. What you're trying to do with a time series analysis is you're trying to show that any sort of pattern in there is not random, that there's an actual pattern to it. And that's where the word stationarity comes into play, basically. You're trying to determine if there's stationarity in the data. If there is, it means that the data pattern that's being established is independent, which means you can build a forecast off of that. If it's not, it just means that it's random, and there's an actual term. It's whether or not if there's a unit root, which I think is just a sort of a math term, basically. But the idea is that you're trying to prove that this data, that there's a trend that's sustainable, regardless of whether or not that there was a particular period of time. That regardlessness is important because you want to see if that is a forecast you can build out, basically. So you basically have your data as an object, and then you run what's called an ADF test to confirm if there is some sort of stationarity or not. ADF test just stands for Augmented Dickey-Fuller Test. And basically what it's going to return to you is a p-value, and it kind of gives you an idea of whether or not if this is a stable if there's stationarity or not. And in this example, this is kind of a general example. It just comes back and says that there's stationarity exists, or stationary exists. So real quick, other time series analysis that you can do. Now, once you get that stationarity address, you can do a decompose, which is what you see here on the screen. It's basically trying to take a trend, take out the noise from the data. And so you can kind of get some of this sort of observed data, whether or not if there are spikes that are growing in intensity over time, an overall trend, if there's something is there, or seasonality. There's a function within R that does that called decompose. And then you have a number of different forecasting techniques. I won't go through these too heavily, but these are ones I would keep an eye out for, basically. ARIMA is you'll see ARMA and ARIMA quite a bit. Those are the standard forecast functions that you can do once you've done your stationarity. Dynamic time warping sounds really cool, but it's basically alignment between two different time series, basically. Another one that you may want to consider is a sliding window, and this is basically having overlapping periods. Think of like a Jenga piece with overlapping periods of data sessions to create a pattern for forecasts as well. And then the two that I'm seeing a little bit more about these days, there's one called wavelets, which is basically these little mini trends in the data, trying to see if there's some sort of mini patterns that are in place. And then imputations is something you'll see in exploratory EDA. Basically, it's where basically you're trying to replace a data, maybe a few missing observations in the data, and you're making assumptions. Like, for example, let's say if you have data where there's a few missing time periods, but let's say 3 out of 3,000, and you decide that the average would be a suitable replacement for those 3 missing periods. You can put that into a model and see if it makes a difference or not. But that's a technique that's done really with general observations. I know with time series, you can only do very, very few observations. It's not a hard number, but it's definitely shouldn't be like, oh yeah, 20% of my data has imputations in it. least I hope not. Okay, so we talked about time series. Let's talk regressions for a moment. So real basic, if you haven't heard what regression is basically taking several columns of data and trying to see if there's some sort of mathematical relationship between them. That mathematical relationship can kind of help you understand which variables are more influential than others, basically, in terms of an outcome. I know that I have a drawing here. Basically, this kind of shows the general idea, but each time, this is where R has been very popular and Python has been very popular, in that you usually can create a table. In that table, you usually have a column that was representing variable one, or another column representing variable two, and so forth. And then you have the observations in there, and it's using those observations to make comparisons to figure out what the coefficients should be. That's kind of the general idea. R has a couple of built-in functions for this. We'll get to that in a moment. And then the other thing you want to keep in mind is that one of the things that people do look for is correlations. Now, I need to explain this a little bit. Correlation is basically basic among variables, is trying to find out if there's some sort of strong relationship between 2, 3, or 4 variables among the entire group. And the idea with this is that you might be able to there's actually a technique for this where you can actually might be able to represent those two strongly correlated variables as one variable. The idea with that correlation is helping you to understand when two variables may be, when a variable may or may not be as important or maybe as influential because it's already correlated with another one. And correlated just means if one goes up, the other one goes up in value, and if one goes down, the other one goes down in value, and they may be so strongly correlated that they may not be, there may be a better way of modeling your data, and that gets into modeling it much more efficiently, trying to get better answers, basically. Do you end up changing your regression analysis from Yes. Yes, and I won't get into that too deeply. I'm keeping it simple from linear, but the short answer is yes. It does. There's different regressions for linear is popular because it's simple. Yay, managers love it. Yay, but if it's something that is not linear, yeah, there are other regressions for that. But it's kind of a general framework. So for this example, I'm going to use, okay, yeah, definitely. Thank you, Ibua, as well, too. There's a number of packages that I'll get to that in a moment a little bit, too, but there's a number of packages for this. So I'm using just the MT cars. This is the real basic R data set for cars. And I think Dippler even comes with an even better car data set. And I'm going to raise my hand and say I'm also working on a data set for cars. I think I wanted to get released as a library soon. So, but the way that you run this, real simple, is right here at the top. I have a Abua. Okay. Thank you for correcting me. I got it. Okay, if I mess up like that, just charge it to my head, not my heart. So the idea is that you have you call your libraries basically, and R you want to do that for, and this depends on what the functions are you're trying to get done. The built-in library is one, or built-in function R is called LM. This is kind of done for linear, it's for linear regressions basically. And then the way this is called is that you have LM parentheses, and then the first column is going to be your Y column, your Y variable. You have a tilde character here, and then the next one is it's supposed to be your X, basically your X variable. And then the last, after that comma, you have your data set. In this case, it's empty cars. And in this example, I'm just using the engine displacement from the cars. So these were, I'll go back here for a second. If you look at these are pretty old. You can tell Datsun 710. This is before my time, y'all. So, and AMC Hornet. And you have miles per gallon and displacement. And I made a quick regression to show that the displacement was a factor on the miles per gallon. So that's what all this is at the top. And what you should end up with when you run the regression, you run a summary. The summary will have basically some of the stats that you see here on the left-hand side. And just to walk through these real quick, the ones you want to pay attention to, there's an F static, and corresponding p-value. And the p-value is usually, I'm going to try to correct this a little bit, but the p-value is usually very, very small. If it's way less than 0.05, then the model as a whole is statistically significant, meaning that it's one red flag check or one green flag checked off that this is a pretty stable model. The key one is this multiple R squared, and it usually is a percentage. In this case, this is 0.7183. This is telling us that 78% of the variation of the response Y, in this case, the MPG, can be explained by the predictor variable, in this case, displacement. What that means in plain English is that you have a model here where any changes in that miles per gallon, the majority of those changes are being explained by any changes in that displacement. That's kind of the general idea, okay? And I want you to keep that in mind when we get to the next slide. And then the last one here is a coefficient estimate, and this gets into those B's and those the coefficients I had in regression. This is saying that this is a 0.04, a negative 0.04. That's telling us that for each additional increase in displacement, we're getting a mild decrease in MPG. So this is kind of giving that, kind of think seesaw. This is giving us kind of the idea of how much displacement is really impacting the miles per gallon. Kind of gives you a flavor or a scale. That's the idea. So let's say that you do this, and then let's say your manager comes in and says, hold up, wait a minute. And they do like this with the hands, and they go up and they say, wait a minute, well, what about these other factors? I think there's something else that may be driving the MPGs. Well, you can do that in a regression. And you go through the same sort of step. And you can see here at the top, I have the same type of regression, except this time I have displacement, horsepower, the cylinder count, and gears. And basically, when you go through this, I'll sit down and put a gist together. We can kind of practice through this a little bit. But the general idea is that you can now start making some comparisons between what you have for R squared and the coefficients versus what you had before. And in this case, as you probably expected, since we have more columns, that means that we had something a little bit more accurate. Our multiple R squared was a little bit higher. 78%, which is better than the 71% that we have with the displacement. It's still statistically significant. And then when we look at the coefficients, we found that gear, very interestingly, of all these things that are kind of a factor into this, gear has like the largest, kind of a larger scale, which is kind of telling you that they're, so what can you do is in practical terms, it may be telling you where to look to get a better increase or decrease of something, which if you go back to what I was saying at the beginning, that's what you're trying to do. You're trying to kind of get a statistical idea of what will sustain you for long term, or at least a clue into that at least. Now, real quick, I'm going to put 2 notes in here before moving on. I know we're running out of time here. Predict is a built-in function within R that you can use to create a prediction model. And again, what you can do is when you do your regression, put the model here that you see here is the object you have for your regression, and then you can put a new data set in, and R can run with that if it's linear. That's the key. But there's other more prediction tools. I won't get into them too deeply, but other ones like Caret and XGBoost. There is a version for Torch for R, and there's a version for TensorFlow for R. Check your Python before you run those two, because I'll say this: with the Apple Mac, I was having problems running my TensorFlow when the Apple went over to the new chip. So I'll say that to say always, check and make sure that you can run those quite a bit. Now, real quick, for machine learning, you want to think about in your categories for your columns, you may run into something like this, where you have a category where the number of items or observations are different. You can see here a Corvette, F-Series, Honda Passport, Volkswagen Jetta, and it's all in this sort of column. They match up to the sample in this example, and there's a number, a numeric that's applied here. Machine learning works on columns. So a lot of times you may have to do what's called one-hot encoding, which is basically taking this column of observations and putting them in as their own variable, and then putting in a matching number for each one of these. So for example, Corvette here has a numeric 1 for sample 1. So you see here 1 Corvette, 1 for number 2. Number 3 is an F series. So, and that has a number 2. So that number 2 corresponds a F series to that sample. So in other words, you're changing the data such that that the machine learning model can see zeros and numbers, and then you have to help train it to understand what those numbers are. And you also have to let it know what those numbers mean. So that way it understands that when it sees a 2, that's an F series. When it says it's 3, it's a passport, and so forth. That's the crux of feature engineering, basically. And feature engineering, by the way, you'll hear that term a lot with exploratory data analysis. A lot of times it's sort of an extension of it, but it's really much more for machine learning. And you hear a lot of it get confused when you talk about feature leakage. That's where features tend to be overlapping in a model because of hot encoding over time. The training is the data is being thrown off, basically. Let's see, 447. Okay, so I hope I'm holding everybody's attention here. So sentiment analysis, I'm going to go through this real quick a little bit because this is a little bit trickier to go through, but it's still kind of a neat thing to do. What you want to do, there's 3 parts of this basically. You're trying to understand the sentiment around words, and there's 3 key parts. The first part is importing your data, and you can usually do that through an API, of course. And then the big part is tokenizing. Right here in this second, I don't know if you can see this very well, but right here in this second image, I have an object called corpus. And at each step, I'm actually putting in, I'm using a function called tmmap, which I believe was from, I think this was from I want to say that was from DevTools, but I might be wrong on this, but because it's been a minute. But the point is, each step I am actually taking out what's called stop words, and stop words are things like the, and, things that you would hear that, yeah, it may be grammatically correct, but they don't have really a feeling for it. Like the word the is it serves a purpose. It starts a sentence, or it ties into a noun, or that type of thing. And then what you're doing is on each line, I would say do it such that you are just kind of addressing each spot. So that way you kind of can get a feel for what's being taken out, removing punctuation, because each time you're updating the object, basically. And then a lexicon, there are a couple of libraries that are available that gives you a lexicon, but what it should allow you to do is to put together a graph just like this, you see here at the bottom, where you have a score for each, it assigns a score for each tokenized word. And that score gets graphed out as kind of like a histogram to help you understand if there is a strong use of a word. So the more words are happy or sad or that maybe are considered happy or a positive feeling, you'll see those higher in the green. If you see a lot of things are negative, you'll see a little bit of this going on, and more negative means that it's a longer bar. That's kind of the general idea, basically. Okay, so a note on sharing all this advanced analysis, basically. A couple of notes that may help you through. First thing is, everyone talks about dashboards and what have you, but there's a lot of packages that can help you to organize your information much faster. The one thing I would tell you if you're using R or Python is start looking at Quarto. Reason being is that is not that it's replacing Markdown, but it's pretty much an update of Markdown. It's kind of the new black, so to speak. You can use it with R, Python, Julia, I think, if I remember correctly. But the idea is that it's basically a document where you can have little bits of your code run, and you can make and you can share it with people without them having to feel like they have to kind of understand R to kind of see what the output is. In fact, you can actually set it to show the output or not show the output, just depending upon what your needs are. But it's a great way of having a document, having a couple of comments that describe what you're trying to do. And then visually, there's a lot of different ways you can do with graphs too. There's actually a library called Patchwork that will allow you to show multiple visualizations side by side in R, basically. In fact, you can use Patchwork with Quarto, basically. But use these to help you summarize what's been updated and identify what forecasts can be developed, because a lot of times managers don't know what what's possible. And it's your job to help them understand what could be possible from the data and what might need to be adjusted. Now, all of this can create some learning jitters, basically. Being nervous about what to learn, feeling like you have to learn everything. You don't. Relax. In fact, one of the things I think that are is becoming a little bit true with data literacy is not to overtrain on one tool, because we're seeing a lot of overlap on tools now, and people are just more or less are looking for ways to gain certain things done. So when you're playing around with these data models, seek some sort of recognition over precision at first. In other words, kind of see how you recognize your output, how you recognize it, how you tell your story. And then as time goes on, you build proficiency to tell that story even well with data. 5 quick ways to improve your capabilities. I'm going to share these real quick. Set aside dedicated exploration time. You need time to go through this, basically, because a lot of times data, it's these sort of trends don't come up very quickly. Sometimes it takes time to run a model, basically. So you need the time to kind of go through and understand what's going on in the data, why certain trends exist. You may need to sit down with people, basically, but give yourself a block of time to do the exploration. That's really important. It really is engineering at its core. Keep a journal. I actually use one of my presentations did last year. I actually use Evernote. I keep a library of white papers, books, articles, and I use the search feature to find how things match up. And that was a great way of yeah, it's very. I hear you, Ma. It's very overlearned. It's very. It's gotten a little bit done. The one thing I always tell people is don't just try to learn R or Python. Try to think in terms of projects or what it is that you're trying to get accomplished. That will help kind of put some guardrails up in doing certain things. Basically, I'll explain that more in a moment. But I usually kept a journal, and that helped me to kind of search and find things very quickly. I see another one. My bookmarks aren't it. I was thinking of using, you know what? I have not used Zotero. I've been on Evernote now for about almost a whole 14 years, which is that's a long time. Definitely look at each one. Look at the search feature and see how well it searches. If it searches within a PDF, as well as maybe something you've written, that should help you tremendously. That's why I've kind of stuck with that's why I stuck with Evernote for such a long time. Develop that. Remember, like I said, keep a cache of learning resources, things that can help you understand the storage layer and service layer over time. Develop some lunch and learns with stakeholders. A lot of times for the people that you're working with, every industry has some sort of jargon, and unfortunately, you have to kind of figure out how to work that jargon into how you explain things. And when you do, the one thing I would tell you is think about pacing. I use the word beats. Somebody thinking, when you're thinking fat beats, are you talking about? What I'm talking about is, the story that's being told. Every story has a rhythm to it, and you have to make adjustments with people all the time. Not everybody comes to technology in a different capacity. Some people, I could sit and talk about APIs for Twitter. I've done this literally, and when I got done with a presentation in Chicago, I had a woman that sat with me and said, "Pierre, I don't know what Twitter is." And I was explaining about Twitter and APIs. So I actually sat down with her and we walked through. Is there a public free version of RStudio? Is free. R programming is free. I would go deposit and I would I would download RStudio and I would download R. So the short answer is yes, those are free. Those are free. And let's see, I use RStudio. Yeah. And there's an RStudio for the cloud. I think that is better if you're working with teams quite a bit, because I think I've seen people, I'll share this real quick. I've seen people get stuck with running RStudio through on their laptops, and they've run into problems. And one person right now, we're trying to help them understand like how a file system works, basically. So sometimes the cloud does help you in kind of simplifying the back end stuff a little bit and help you kind of focus on how should I put together a script, what should be put together as a library, how I'm calling my data, and that type of thing. Let me quickly summarize. So what I want you to do is think about how you categorize your metrics. You may have base vanity metrics. You'll have some things as a rate, and then for the advanced analytics, you want to think about, when you think about statistics a little bit, you want to think about or even hypothesis, think in terms of what will give a significant lift. You're trying to look for things that will give you a lift over something else in a significant manner rather than just spikes, basically. Exploratory data analysis or feature engineering, you use that to address the dimensions, the data types that you have, and then the missing data that you have, whether they're NAs or things that are missing. And then you can look at things like time series to identify patterns independent of time. That's the key thing you want to look at. Remember, you want stationarity. You want regressions to identify which variables are, how they relate to that output variable, basically. And you can use that for a number of different things. I should have had sentimental analysis. Sentimental analysis, thinking about in terms of words and talking about what the emotions are around the words. But all of this, the biggest thing I would tell you is structure your learning as much as you can. When I started with Google Analytics, for example, I had to learn JavaScript, but I learned it around the tool a little bit. And today, I think there's a lot of tools out here. Don't be so tool agnostic, but definitely look at, make comparisons. How can I do a statistical model in one tool versus the other? You do that, you'll concepts that have been kind of on the edge with you, those things will stick with you throughout life. And with that, I know we're getting close to the time. I'm going to say thank you. Thank you for being here, and I'm going to take questions. Do we have any questions? Don't know if I can see the chat. Okay, MA, thank you. I appreciate it. I hope this was helpful. This is sometimes is it Amika? Amika? Am I pronouncing your name correctly? Let me know if I am. I'm glad
Amaka.
Repeat again, please.
Amaka.
Amaka. Pleasure to meet you,
you.
and thank you. MA, thank you. It was fabulous. Thank you. Thank you. I hope this was helpful. This is a lot. It's a lot to cram in. Jalen, great presentation. Thank you.
I do actually have a question. If you have a minute.
Yes, I do. Cedric. Hi, Cedric. How are you doing this evening?
Oh, how's it going, Pierre? Pierre, am I?
Mm-hmm.
Yep. If you're doing EDA and you find out you have a distribution that looks pretty weird, like say it's a decreasing tight trend with gaps in it, and then there's like a spike at the end, and you're just having a really hard time identifying, a model to try and apply to it to try and predict its sort of outcomes. What would you do? I mean, what I've been trying to do is kind of rephrase what what my hypothesis on it would be, or something like that, or like trying to understand the data. But what would you do in that type of?
I'm hearing two things. Did you say that there was gaps in the data at some point?
So it's more like survey data where people just didn't respond at these points, and it's not that they're NA values, it's just really low numbers of responses. So like the values were between like 1 and 30, and people just didn't responded at really low rates between like 9, 10, and then 13 through 16, and then all of the other numbers showed like a decreasing trend. So it's like 1,000 at 1, 900 at 2, so on and so forth, and then it like spikes up to like 1,000 at 30, and I'm just like, I've been banging my head against the wall trying to figure out.
Yeah, that's kind of unusual. The other thing is that, and I didn't get into this. There's you may have heard bootstrapping too. As a technique. When people talk about, I didn't even talk about probability distributions. I wasn't sure if I could cover that very well in the hour. Probability distributions, when you look at them, there's functions in R. You'll see them. There's R norm, which is for normal distribution, where you kind of create a distribution of data. You have a R unif, which is uniform, and R Poisson, which I think is R Pois. And there's all the R has something like, I think it's like 32 built-in probability distributions. The idea behind those is that if you have a sample of data, like maybe a small sample of it, you're trying when you do a probability distribution, in general, you're trying to create this sort of you're saying that I have this small sample of data. um, I'm going to create a model of data around a model of data of a larger data set based off of the sample. Then I use standard deviation means to match up to that, or some variation of it. That's kind of the general 10,000-foot general idea. Surveys sometimes I think are a little bit difficult because you run into the problem of somebody not responding. I think there's ways to bootstrap, but don't hope. I'm also, I'm also bald, so so don't, don't hope, don't if you pull your hair, it's like, why am I pulling my hair? And because Pierre's suggestion didn't work, it's like, well, he was bald, he shaved his head. That's what he did. So I say this lovingly to say, that might be an idea, but I'm not. But until I look at, I probably have to look at your data set to kind of really get a feel for it. Surveys, I think the biggest problem when you run into surveys is that it's usually sample size, but there's a lot of good techniques on trying to build. Send me an email. I'll take a look and see if I find something in my library that might be of some help to you. Happy to at least put you on some sort of direction as well too.
Okay, yeah, Lindley. I'll write down your email here. Thank you.
Okay.
I was going to say thank you for your presentation. It was very great. Sorry, I missed the first 10 or so minutes of it, but it was absolutely great.
Okay. All right. These are hard to do. One thing I would tell everybody, if you haven't done a presentation, do it. Make this your year to do it. Even if you're learning something, spelling Python with a P, the merits of it. I mean, I would do it. Gives you a chance to walk through a lot of information, and it teaches you a little bit about how to give the information to people as well. And I'll say this from remote. I've done remote before the pandemic. It's hard to do remote and give people good information. So that's one free tip I'll give to everybody. If you haven't done a presentation, make it your year. If you want to know some good conferences, email me. I'll gladly share. I guess that's it.
Well, thank you for your presentation.
Thank you. Thank you so much too. Thank you.